Hi, welcome to our channel of IGNOU audiobooks, Indira Gandhi National Open University, School of Journalism and New Media Studies, SOJNMS, Certificate Programs, Certificate in Community Radio, CCR, English, Course 2, CCR-BJM-002 Operating A, Community Radio, Block-1 The Technology for Setting Up, Unit 1 Setting Up a Community Radio Station. 1.0 INTRODUCTION. Community radio is not new technology. It uses the same FM transmitter, with even less power, the same production and editing tools and the same broadcast chain which have existed for the past few decades. What then makes a community radio station, CRS, different? It is the choice of right, optimum, friendly, rugged and cost-effective technology, and well thought out decisions regarding the infrastructure. It is important to plan the CRS setup comprehensively considering the geography of the site, power situation, target audience, type of intended programming, the hardware needs and expansion plans. No dedicated broadcast engineering institute exists in our country and many of those who want to establish CRS have little knowledge about the technicalities of the equipment and propagation mechanism. However, understanding the basic terms like ERP against power, OI transmitter, antenna height above ground against effective antenna gate etc., and applying the correct criterion for decision making may result in significant gains, i.e., greater coverage and lower costs. 1.1 Objectives. Going through this unit will enable you to understand the basic technology involved in radio broadcasting, the technological parameters important for planning a community radio station, importance of height of antenna and effective radiated power, evaluating the field strength and coverage of transmitter, important factors to be considered for selection of site, various technological considerations for establishing a community radio station, radio frequency and program exchange networks, manpower requirements and volunteers and training needs, broad categorization of various types of community radio stations, layout of a typical broadcasting studio. 1.2 The basic requirements. The first and most important decision involves choosing a good location. There are various factors and trade-offs which need to be considered while arriving at the decision. A. The available resources and the specific goal of the CRS in mind. B. Choice of equipment and type of acoustic treatment. C. The typical broadcast chain consists of audio production, playback equipments, microphone, cassette recorders, DAT, CD player, turntable, mini-disc player, reel machines, hard disk-based systems, phone-in units etc. D. The console for mixing and managing these inputs, the audio processor. A. Studio transmitter link, STL, transmitter, RF cable and antenna. All these equipments, some of them essential while some others additional useful add-ons, have to be procured depending upon the CR station's requirement and financial capacity. Each of these equipments can have a very wide range of features and costs, and while deciding on the technical system, it is important to have a clear understanding of what you want to achieve, how you want to do it and what are your expansion plans. 1.3 Criteria for site selection. Once the decision for set up a CR station has been FMA-list, the next most important work involves selection of a suitable site for setting up the station. This choice again depends upon several factors and it is important to have a clear understanding of the financial implications of establishment before taking the next step forward. 1.3.1 Infrastructure. First, check out if there is any existing building available for setting up the station premises. That may be cheaper as an option, but remember, any building, however well constructed or old and badly maintained, will definitely need certain modifications. An old building will have to be modified to suit the requirements of a radio station. This will be a patchwork, where a reorientation and the design will definitely not be optimal. If costs permit, it is always advisable to construct a new building. The advantage is, you can build the infrastructure with a proper plan where the studio and various ancillary areas, such as waiting room, discussion room, technical area etc., are well designed. 1.3.2 Terrain profile. In case of FM broadcasting, the height at which the antenna is installed is very important. For example, a 100-watt transmitter with 15 meters effective antenna height may cover much less area than a 50-watt transmitter with 50 mts of effective antenna height. This is so because, in case of VHF, frequencies used for FM, the waves follow line of sight propagation. Thus, higher the antenna, higher is the reach. However, the hilly terrain can also be disadvantageous as the population falling on the other side of the hill, shadow area, may not receive the FM broadcast. Thus, the location of the transmitting antenna should be decided after taking into account the distribution of the population and specific L primary target groups. 1.3.3 Availability of power supply. This factor is vital especially in rural areas where much of the electric supply is diverted to agricultural uses. Alternative energy solutions are costly and as far as possible, one should try to make use of a reliable power supply feeder. Normally, such emergency supply feeders are available at government hospitals, air and TV installations etc. Locating the CRS near a hospital and convincing the power supply agency to give power supply through the emergency feeder will go a long way to save establishment as well as running costs. Electronic equipments are very sensitive to power fluctuations and it is advisable to invest in AVRs, automatic voltage regulators. Apart from IP voltage, typically 230 volts, electronic equipments are designed to work at a particular line frequency, 50 Hz. In India, at some places the line frequency is found to be deviating to the extent of 40 Hz and unlike power fluctuations which can be taken care of by using an AVR, the frequency variations are very hard to control. It is thus essential to pay special attention to these aspects before finalizing the location I set up. The antenna location also should be reasonably distant from any airport or defense installations. 1.3.4 Ambient noise. You might have noticed that while an aeroplane is flying very near to your house, the radio TV reception gets affected. Similarly, some of the gadgets like mixer, grinder or even a mobile phone operation creates disturbances in radio reception. This is due to sudden generation of an unwanted electromagnetic field. That is why a radio station should not only take care of audio noise but should be preferably located away from sources of radiation such as airports, welding shops, workshops, factories, power plants etc. It is possible to install shielding but that is a very costly add-on to the entire setup costs. 1.3.5 Pollution. Heat and dust are the greatest enemies of electronic equipment. A low-cost community radio station may not be able to afford sophisticated arrangements for reduction of dust and heat, like air curtains, air conditioning etc., but choosing a location considering these parameters is an option that must be kept in mind. The station should be away from polluting factories, thermal stations, covering the surrounding open soil by lawns, planting leafy, not too high trees around, which will cut down ambient noise as well but will increase the clutter height, thus reducing the coverage area, and ensuring proper ventilation in the technical area, which will take care of the system noise are some of the options that need to be explored. At times, it may be necessary to invest in air conditioners, preferably split ACs, but once again this needs to be very carefully planned in the infrastructure. 1.3.6 Precautions from natural disturbances. As the transmitting antenna is normally installed on a high tower structure, it is prone to lightning. The danger is more in hilly areas during the rainy season. A lightning arrestor connected to a low resistance earth pit is essential for protecting the transmitting equipment. One should never forget to create an earth pit or a set of earth pits, which will go a long way in saving the equipment by providing the high voltages and easy path to ground. The earth resistance should be measured from time to time and should preferably be less than 0.2 ohms. A low-cost earth pit can be made by drilling a 20 feet GE pipe of 1.5-inch cross-section into the soil. Make sure to add water from time to time to maintain wetness in soil. The equipment is to be connected to the spit pipe using a 25/3 of a millimeter copper or G tilde strip. The contacts are to Be perfect, otherwise the very purpose of having a low resistance earth pit will be defeated. It is advisable to have separate earth pits for RF and audio, to take care of hum and distortion. It is possible to construct more sophisticated earth pits using copper sheets. A copper sheet is rolled to form a cylinder and two electrodes, 25/3 of a millimeter copper strips, are brought out from them. The pit should be 10 feet deep into the soil and some charcoal and salt has to be added to improve the conductivity. In the center of the copper drum is placed a hollow ghee pipe with a funnel on top to supply water to the pit from time to time. In terrains such as deserts, rocky soils, hilly regions etc., where it is difficult to attain low earth resistance, one tilde and add bentonite with charcoal and salt. This gives much better results. A much more sophisticated way is to create a grid of 3 earth pits and join them to achieve still lower earth resistances. Once again, the choice depends on the availability of finance. A. Design for construction of earth pits is as below. Look at the screen. 1.3.7 Safety and accessibility. The station location should be easily accessible for transportation of equipment and maintenance needs. There should be sufficient plain area for erection of tower, masts. The community radio is for the community. Hence, the location of the CR station should be such that the community can reach it easily. In a rural setup, the ideal place is where village gatherings normally take place. These may be chopals, haats, marketplace, near primary schools, post office or similar meeting places. As community radio stations primarily work with volunteers, including women and retired people, the accessibility of the location very important. It will be desirable that the station is located amidst the populated area so that the volunteers, particularly women, can simultaneously take care of their family concerns. Such a location also takes care of the safety of the station as well as the people working in it. While this may appear contrary to the technical parameters, like noise-free environment and height above MSL, mean sea level, it will be wise to consider a trade-off between studio location, for greater accessibility, and transmitter location, for better coverage. Judging the ground realities. In typical situations, the transmitter can be located at a higher or quieter location, up to 500 to 700 meters away from the studios. Good quality audio. Cables have a drop, loss, of around 3 decibels I 500 meters, which is acceptable. 1.4 Technology behind radio. The frequencies in which we speak, sing and hear are called the audio frequencies. They are in the range of 20 to 20,000 Hz. When we speak or perform in front of a microphone, the waves generated by our vocal cord, musical instruments etc., are acoustic waves, which get converted into electromagnetic waves through the microphone. Similarly, audio frequencies from various sources like CD player, turntable, etc., are mixed at the studio console and fed to a transmitter as electromagnetic signals. At transmitter, these audio signals, information, are modulated and then transmitted through an antenna. At the receiving end, that is when you hear the programs on your radio set, the audio information is separated from the carrier frequency and is directed to the speaker. For community radio broadcasts in India, the frequency modulation allowed is FM, which means the carrier frequency, allocated station frequency, varies in accordance to the audio. FM is considered better than AM due to better signal quality, better reception. The transmitter cost is also comparatively low and antenna systems are much simpler and safer. The radio signals in FM LVHF band follow space propagation, i.e., near line of sight path. This is one problem area for FM because signal can be obstructed by hills, tall buildings etc., and give rise to uncovered pockets in shadow zones. This is why the location and height of transmitting antenna are very important factors while planning the FM service. The maximum antenna height has already been fixed by the government policy, 30 mtrs, but the location should be selected very carefully so that strong good quality reception covering the widest area can be ensured. 1.4.1 The transmitter. The transmitter is the copies of the equipment in a community radio setup. The transmitter makes it possible for the CR station to send its programs to the target areas. In fact, at the simplest level, some of the proposed models of community radio station for grassroots organizations with very limited financial resources only have a transmitter linked to basic audio equipment like a microphone, CD player and a phone-in console. Let us now understand the technical details of a transmitter. You may never need to use this information, but broad knowledge of your transmitter components and their working comes handy in case of maintenance requirements or in the event of some emergency in the broadcast. A transmitter has two basic segments, an exciter and RF power amplifier. An exciter is nothing but a low-power transmitter generally having an output power of less than a watt. The exciter houses an oscillator, which generates a particular frequency known as carrier frequency or station frequency. The audio received from the output of the console is also fed into the transmitter. This results in modulation of the carrier, that is, small changes in the frequency of the carrier. The louder the audio, the more is the proportionate change in the carrier frequency. This concept can be understood better if we consider the carrier as a horse and the audio information a stay rider. The horse is the carrier that is generated inside the transmitter, and the rider, the audio, comes from the broadcast studio, that is the microphone, CD player or any other sound through the audio console. The output of the transmitter is a modulated signal, the rider on the back of the horse. After traveling a long distance, the horse and the rider, the modulated signal, enters the FM receiver through the receiving antenna. At the radio receiver they are demodulated. That is, separated. The rider, audio, is sent to the loudspeaker, and that is how the radio listener is able to listen to the same sound almost exactly as it was produced at the studio. You are listening to this audiobook on Audio Learn IGNOU 1.4.2 FREQUENCY. Every CR station is allocated a definite frequency, within the frequency ranges of 90.4 MHz to 107.8 MHz etc. It is mandatory for each station to stick to its allotted frequency and not deviate. This allotment of frequency is done by the Wireless Planning and Coordination (WPC) wing of the Ministry of Communication. The transmitter of a particular station, or more precisely, the oscillator of that transmitter, will have to be tuned to the frequency allotted to that station. This is done during the installation by the company that supplies the transmitter. The market offers many kinds of transmitters which can be tuned to the desired frequency using some switches or jumper connections. It is always advisable to go for a transmitter that is approved by the Ministry of Telecommunications. 1.4.3 Antenna, handling RF radio frequencies spread in space through the antenna, uncontrolled, and thus have the potential to interfere with other radio stations too. This involves legal and regulatory issues. RF equipment is more sensitive, more prone to reflections, fluctuations, and is more costly. Thus it is most important to pay utmost attention for procuring, installing and maintaining this equipment. RF equipment is quite delicate. Apart from protection from heat and dust, power fluctuations, RF reflection and lightning are possible dangers for transmitters. RF reflections may cause immense damage and result in bum out of the RF power stages. Mismatch may be caused due to improper antenna, improper tuning of the antenna, or loose connections between the transmitter and the antenna. Many transmitters have inbuilt protection and switch to reduced power in case the VSWR value crosses 1.6 and trip. As soon as it crosses 2. In hilly areas, a lightning arrestor connected to a low resistance earth pit is essential for protecting the equipment. It is advisable to have separate earth pits for RF and audio. When we pump in some amount of power from transmitter to antenna, if there is not proper matching, smooth flow of power will not take place and a portion of power will return back to transmitter from antenna, which may damage the equipment. VSWR, which is forward power plus reflected power, forward power. Reflected power is the parameter to measure this reflection. The ideal value of VSWR is 1, i.e. no reflection from antenna. Just as a bad loudspeaker in a good music system may defeat the very purpose of the composite system, an improper choice of the antenna may reflect adversely on the design of the transmitting system. Antennas are broadly characterized by their radiation patterns, polarization and gain. The gain of the antenna adds to get higher effective radiated power (ERP) of the transmitting system. Higher gain antennas will be costly, heavy and difficult to install, and will need a more solid structure I-tower for erection, which may not always be possible for a CRS. The preferred antennas for CRS can be a single bay folded dipole, a two-bay folded dipole, or a 5/8 wave E or linear vertical antenna. 1.5 Technical specifications for transmission. Opening parenthesis. While procuring a transmitter, some of the important factors to be kept in mind are output power, frequency range, RF output impedance, frequency stability, modulation type, modulation capability, signal to noise, SIN, ratio, input power, DC operation, ambient temperature, range, harmonic distortion, intermodulation distortion, audio frequency response etc. Nowadays, transmitters come with many add-ons, which of course add to the cost, hence it is important to freeze our requirements right at beginning and decide on an optimal set up, while allowing for the possibility of modular upgradations in future. For example, most of the FM transmitters available these days are stereo. The CRS may not have stereo audio production equipments and/or the members of the community may not possess stereo FM receivers. Under such circumstances, the stereo capability of the transmitter, which may be the cheaper option for the CRS, is actually a technical disadvantage, as the coverage of a stereo transmitter is much less than that of a mono transmitter. These add-ons, however, can be tackled. For instance, the stereo capability can have to be disabled to ensure better reach. A transmitter is must to conform to the specifications prescribed by the International Telecommunication Union, LTU, vide their recommendation BS.45023. Two of the technical parameters mentioned in the Indian CR policy are 100 watt ERP, maximum antenna height 0 meters above ground. Both these parameters play significant roles in deciding the coverage of transmitter and hence needs to be understood well before planning of CRS. 1.5.1 Effective radiation power, ERP. A broadcast transmitting system primarily consists of 1. Transmitter, 2. Radiating antenna and 3. Feeder cable connecting the output of transmitter to the antenna installed on a tower. The antenna normally has some gain, which adds to the power of the transmitter. The cable is responsible for the loss of power. The power of any transmitter is expressed in dB in logarithmic scale. Here is an example. One transmitter with output power of 100 W is procured. This is 10 decibels power. The antenna used a simple folded dipole, something like the C-5 HAP-D element of the Yagi antennas used in early days to receive the TV signals. The gain of this type of antenna is typically 3 decibels. The cable used is RG213. The typical loss of such cable is 6 decibels per 100 meters. The length of the cable used between the transmitter and the antenna is 50 mts, hence, the loss of this piece of cable will be 3 decibels. The effective radiated power is as follows. ERP equals transmitter power, cable loss plus antenna gain, equals 10 to 3 plus 3 equals 10 decibels. Hence, ERP of this system will be 10 decibels, i.e. 100 watts. It is evident from this example that one may choose to procure a low power transmitter and use high gain antenna and low loss cable, say 7/8, or may use a high power transmitter with low gain antenna. The price of high power transmitter may be significantly higher, whereas the price of a high gain antenna may not be that high. However, the weight of high gain antenna and its mounting procedure may be difficult. These will be the important factors for deciding the combination. 1.5.2 Antenna height above terrain and coverage of transmitter. The effective height of transmitting antenna is defined as its height in meters over the average Level of the ground between distances on and 15 km from the transmitting antenna in The. Direction of receiving antenna. The notional height of the transmitting antenna is defined as the antenna height above the clutter in its vicinity, if known. If the height above the clutter is not available, the notional height is defined as the antenna height above the ground. It may be noted that though the antenna height above ground for a particular setup is fixed, the effective height of antenna above average terrain, EHAA1, may be different in different radials, directions, depending upon the terrain profile in that direction. There may be cases where the height of antenna above ground may be 30 mt but the effective antenna height of the system may be much less than the system having antenna height above ground just 10 mts. Due to the difficulties in calculating EHAT, for all practical purposes community radio is allowed an antenna height 000 meters above ground, regardless of the height of the terrain. Thus choosing the right place to erect the transmitting antenna may give excellent dividends to achieve much more coverage even with restricted transmitter power and restricted antenna height above ground. Check your progress too. 1. What is the difference between antenna height above ground and EHAT? 2. Can the ERP of a transmitting setup be less than the power of the transmitter? 1.6 The studio setup. The studio, as you may be aware, is the place where your program is recorded and also played back for broadcast. That means there are two kinds of studio, one for recording purposes and another for broadcasting. In a small economic setup like a community radio, these two kinds of studio can be combined. We will however explain each kind of studio separately, presuming that the radio station has space as well as F-mans for two studios. One for recording and another for broadcasting. 1.6.1 The recording studio. Studios in a professional radio station are acoustically treated. This is done to ensure that there are no excessive sound reflections, cathedral effect. Soundproofing is done by special treatment of the walls of the studio. In a professional setup, the walls are covered with perforated cardboard tiles or other acoustic material backed by 1.5 inches thick glass wool layer. Figure below illustrates the design of a typical sound studio. A recording studio has normally two functional areas. Look at the screen. The acoustically treated room where the artists, talkers or the performers record the program. This area has professional microphones, the outputs of which are transported to the second functional area via audio cables. The second functional area is separated from the main studio, or the acoustically treated room, usually by a double glass window to ensure sound isolation. This room is the hub of technical activities. It houses the console, which receives signals, inputs from various audio sources. The output of the console is transported to the recording device, which may be cassette, reel or digital recorders or a computer. The acoustic treatment of the recording studios ensures the right reverberation time, RLT, or each kind of sound. It is different for professional music, drama or talk studios. The desired RTF is achieved by the right combination of room design, its shape, acoustic treatment of walls, carpeting, false ceiling etc. This involves huge expenditure and professional help as well as maintenance. No community radio set can afford so many studios. Therefore, in a CRS setup, the acoustic treatment is optimized so that the one single studio can be used for all kinds of recording and yet produce quality recordings. Cheaper options such as use of cardboard egg trays, thick cotton curtains, choir mats and other cheap sound-absorbing material may be a good choice for community radios. 1.6.2 The broadcast studio. A broadcast studio is the place where participants of live programs come and perform. This studio is directly linked to the transmitter and forms one end of the broadcast chain, about which we will presently discuss. Sometimes a CR station installs a multipurpose studio where recording as well as broadcast can be done and has a small playback studio or roar, read-over room, which is used by the announcer, anchor to present the live broadcast. This studio houses audio playback equipment such as CD players, tape decks, MD players, turntables, CTRs, console, tape recorders, computers, digital audio workstations, presenter microphones and phone-in unit, telephone hybrid to conduct interactive programs. A CR station may have one 3-in-1 studio for all these functions or can have 3 small separate studios or a combination of 2 depending upon requirement and availability of funds. 1.6.3 Edit Console. This is the place where a program is given FMEL shape and made ready for broadcast. This area needs air conditioning as well as dust-free conditions as it houses computers that may require operation for long hours. The functions of an edit console can also be performed in a multipurpose studio during the off period when no recording or broadcast is taking place. Editing is another important part of the station's technical setup. Once editing used to be done using interconnected recording machines, but these days there are several extremely useful software which make the craft of editing much easier and less prone to quality fall due to generation loss. Editing will be dealt with in detail in a later unit. 1.6.4 The broadcast chain. The broadcast chain is the link between the different equipments of a radio station setup. The figure below illustrates a typical broadcast chain. The microphone is the beginning of the broadcast chain and is the most vital piece of equipment. Microphones are available in different categories and price ranges. They are categorized by their construction, sensitivity and frequency response. The next equipment for the chain is the edit console. Commonly known as mixing desk, it is considered the heart of the studio. It helps a presenter to choose one or more inputs from various sound sources, vary their level, loudness, and mix them if desired. This mixed, final signal is transported to the transmitter, recording destination. In a professional broadcast studio, you will mostly find hard disk-based recording systems, CTRs, reel machines, professional CD players having balanced output and fader start facility, turntables etc. A community radio station can work pretty well with a combination of commercial, semi-professional CD players and cassettes recorders. 1.6.5 Other technical considerations. In a CR setup, the OB, outdoor broadcast, equipment is very important. A good quality compact cassette recorder is perfectly adequate for recording interviews, conferences, and meetings. The technical quality such an equipment is however not good enough for recording live music or sound effects. Minidisc systems are considered too fragile for field recordings as they are prone to get disturbed with fluctuations in temperature, humidity, and dust conditions. Professional digital flash memory recorders are the recording systems of the future. They are available in various models and have excellent features like no mechanical noise, fast transfer of recorded material to PC via USB port for editing, and ability to select different recording formats. You will get to know about these equipments in detail in following chapters. The Indian CR policy demands that at least 50% of the programs of any CR station should be locally produced. For the remaining broadcasts, the content may be borrowed from various sources. While setting up the CRS, provision should be made for sharing programs or program material across a program contributing network, which may be one or a combination of the following: Internet, DTH services, VSAT network, regional program pool, PS as in government announcements. Internet is one of the most popular and powerful tool for access to information. Apart from downloading the audio, many community radio stations are using the power of internet through radio browsing. In radio browsing, the anchor at local CRS accesses useful or on-demand information through internet on the computer and shares it with the listeners in their local language, thus breaking the language literacy barrier. The satellite services, through VSAT, are at present costly option for CRS. 1.7 Manpower requirements. The station manager is the nodal person at a CRS. A CRS needs to have a few staff members as well, and it is always advisable to have at least one technically competent staff to oversee transmission and maintenance of equipments. However, a typical CRS is mainly run with support from volunteers and non-permanent staff. Training therefore becomes a very important activity. Capacity building and skill development to enable community members make valuable and interesting contribution to the station is part of the routine work at a CRS. The typical manpower needs of a CRS are Station manager, sometimes the only full-time staff member. She requires production, administrative and technical skills. Engineer, technician, preferably full-time. Program staff tell volunteers with some training in equipment handling. Training requires significant human and station resources. Most often trainings are conducted by someone from within the station, mostly on an honorary basis, but some stations have arrangement with equipment suppliers to include one comprehensive training program. With the installation cost, the training methodologies can be one-on-one training, to fine-tune the performance of broadcasters. Buddy system, use existing broadcasters to help new broadcasters. Advanced training, further training opportunities that address subjects such as advanced mixing techniques, news and current affairs production, outside broadcasts, internet research, equipment maintenance and repair etc. and partnership training, network with local colleges, universities or broadcasting organizations to share expertise and cost. Typical training needs for a CRS can be categorized as basic training, operations, learning technology in a technical language, removing fear of electronic gadgets, understanding the hardware, important do's and don'ts of broadcasting, nominal maintenance, daily, weekly, monthly schedule. 1.8 Let US Some UP. Community radio station is a media initiative to develop awareness, achieve social development goals for the poor, marginalized communities by giving them a voice. Most community radio stations cannot afford to buy costly professional broadcast equipment. But it is possible to set up a fully functional radio station using innovative ideas through which cost cutting can be achieved without compromising the quality of broadcast. Unlike professional studios, CR equipment is used by relatively less trained volunteers. And the number of users handling the equipment is also higher. Heat and dust protection of CR studios is also much less compared to professional radio studios. Therefore, while buying the equipment, it is important not to compromise on its ruggedness and longevity. The best option is to break up the list of equipment required by the CR station into separate parts and procure the best affordable equipment in each category. Though there cannot be a single common solution for a community radio setup, there definitely exists the need to provide a set of indigenous and competent solutions, which will be suitable for the local environment. Thank you. Subscribe to our channel for more updates, and we will see you with the next chapter.